Hello and welcome to the channel. Here we have an interesting fable about a grain of wheat and a chessboard. There are many versions of this, but this one is about a brave servant who as a reward asks his wise old ruler to get out his chessboard and place on the first square of his chessboard 1 grain of wheat for him. On the second day to place on the second square 2 grains, and on the third day cover the third square with 4 grains. Each day double the number of grains placed until all 64 squares are covered, and the reward will be complete. The wise old ruler replied, "This sounds like a small price to pay for your act of incredible bravery." The question is, was the ruler so wise after all? This problem illustrates the power of exponential growth in quite a dramatic way. Let's start filling the board up first and look at the first 16 squares, where we end up with 32,000 grains on square 16. By the 32nd square we have over 2 billion and things are starting to hot up. By the second half of the board the numbers start to look incomprehensible, as we have 1.4 times 10 to the power 14 by the 48th square. That's a 1 with 14 noughts after it. The numbers are massive in the last quarter and we end up with 9.2 times 10 to the power 18 on the 64th square. Here is a plot of these values on a normal linear scale. The two things to note are that a linear scale cannot normally detect or show the early stages of exponential growth. The second point is that humans think in a linear fashion, not in proportions, and so our intuition finds it difficult to cope with the constant doubling and acceleration as we move into the second half of the chessboard. We can overcome some of these issues by plotting the values on a logarithmic scale. This shows proportional change, not linear change. Thus a straight line on it indicates that the values are increasing by a fixed proportion each square, in this case by a factor of 2. Thus we are able to see the early stages of exponential growth on this plot. You would see similar trends for things such as technological advances in the last 50 years. For example, American electrical engineer Gordon Moore, who went on to co-found Intel, predicted in the 1960s and 70s that microprocessor power would double every 2 years, which it has done so, resulting in the mobile and other devices we see today. Other things like electrical vehicle production will have a similar trend. Going back to our chessboard, let's work out how many grains in total there are on it. Have a look at the first 4 squares. Note that the sum of the values is 15, which is 1 less than the 16 on square 5. This is true throughout the board. Thus, if we put in a hypothetical 65th square, which has a value of 1.845 times 10 to the power 19, then the total on the board is 1 less than this, or 1.845 times 10 to the 19, as subtracting the 1 is insignificant. For those of you interested, I will show the mathematical proof of the sum of finite geometric sequences like these at the very end of this video. We can summarise this finding by expressing the sum as a series of 2 raised to a power or exponent. Thus for the 64 squares the sum is 1 plus 2 plus 4 plus 8 and so on, plus 9.223 times 10 to the 18, or 2 to the 0 plus 2 to the 1 plus 2 to the 2 etc. up to 2 to the 63. From our observation earlier, the sum of 64 squares is given by the value of the 65th square minus 1, or 2 to the 64 minus 1, which gives us the 1.845 times 10 to the 19 grains from earlier. If we assume a grain of wheat weighs 65 milligrams, then we get a total on the chessboard of some 1.2 trillion tons. This is around 1,500 times the current annual global wheat production, and would have been greater by a larger factor in the time period of our fable. It seems therefore that the wise old ruler was not so wise after all, as he promised something that was impossible to achieve. Perhaps the brave servant was even less wise, as he probably got beheaded for making a fool out of the ruler. Let's have one last look at the chessboard and summarise our findings. Firstly, the 33rd square contains more than the first half, and the last 64th square contains more than the rest of the board put together. However, the most significant observation is that the second half of the chessboard contains more than 4 billion times the wheat contained in the first half. This observation of more noticeable exponential growth in the second half has resulted in the phrase, the second half of the chessboard. This is often used in management theory and practice, where an exponentially growing factor begins to have a significant economic impact on an organisation's business strategy. Of course, exponential growth cannot go on forever because it runs out of either space, resources, or in the case of consumer products, customers. For example, population stops growing as resources get depleted. Bacteria stops multiplying as it runs out of a suitable environment. Now, if you thought that the chessboard growth was dramatic, then reconsider. The ultimate exponential growth takes place in cosmic inflation theory, as co-pioneered by one of my favourite physicists, American Alan Guth. The theory was developed in the early 1980s to address some issues with the standard Big Bang model of the evolution of the universe. He coined the phrase the ultimate free lunch to describe it, because the very early universe is postulated to have grown from quantum fluctuations of around the size of 10 to the minus 31 metres to the size of a grapefruit in only around 10 to the minus 32 seconds. This is growth by a factor of 10 to the power 30. Now that's what you call exponential growth. Thanks for watching. For those of you interested, I shall now quickly describe the mathematical proof for the summation of finite geometric series before ending the video. For a geometric series of n terms with a common ratio of r, the sum is given by a plus ar squared, etc. plus ar to the n minus 1. If we multiply both sides by r, subtract the two expressions, and then factorise, we get the standard expression for the sum as shown. This is often quoted in equation sheets. For our particular case of the wheat and chessboard, a is 1, r is 2, and n is 64. Thus we end up with a sum of 2 to the 64 minus 1, as we saw earlier. Thanks again for watching, and I shall see you in the next one.